crops allows us to make crops designed to where we need them. So we can make them the food that we need and where we need them. So genetically engineered plants like these can be engineered through biotechnology like CRISPR, which uses an enzyme that is modified called Cas9, and then we use guide RNA to put it in specific parts of the plant's genetic sequencing to help make the plant how we want it to be. So we can make plants more water, like not need as much water throughout the day, or able to hold the water it does use, like a cactus. We can also use genetic engineering with genomic selection, which is basically us speeding up the process of selecting plants like traits and everything. So it's a form of breeding, and we breed the traits of plants that we want. So we can breed them to be like less water dependent or able to sustain like harder ground and last longer, have more yields for crops. And so these plants are pretty useful all over the area. We can use them in different countries like Europe, and we can use them in the US in states like Kansas and Texas, which are really dry and we have a lot of room for farming, but a lot of the areas are too dry to use it. And so we can make the crops from the land. A lot of problems with this is though that a lot of people have stigmas around chickens and genetically engineered food because it's not seen as natural because we made the plant genetically by engineering. So a lot of people don't want them in their area. They don't want to eat them too much because they don't really see it as a food source that's healthy for them. And also there's another financial barrier to it because jumping in and starting having genetically engineered crops is quite expensive. But over the long run, it saves you water because water is money, so it saves you water overall. So in the long run, it does save a lot more money, but it is really expensive.
So from a few dozen years ago, when people started to grow crops and breed livestock, people always needed water reservoirs because people were afraid of droughts or natural disasters that would lead to water scarcity and make a situation happen that they couldn't find water for their agricultural business. But in modern society, governments run large water reservoirs called dam to store a lot of water and use it when droughts happen or it doesn't rain for a long time. But the problem is that because the water dams are outdoors, it often leads to a lot of evaporation of dams, so that leads to a lot of water waste and it eventually leads to a great amount of cost to it. So I proposed dam evaporation control, specifically floating modular covers in this case. So basically it's like a small modules that independently float in the water surface, and if like millions and thousands of them gather together and they form like a cover to cover up the surface of the water. And these are usually made with polypropylene and high density polyethylene plastic, and these materials are approved for the food grade standards that it doesn't really pollute the water, and it doesn't harm the water, and it makes it available for consumption. And how it works is pretty straightforward. It just prevents the exposed sunlight and wind in the atmosphere for the surface of the water and protects it to reduce the evaporation. There's a couple of benefits for this specific method, floating modular cover, because it has like kind of gaps between each modules because it's independent and it's floating out in the water. Because of the small gaps between the modules, the oxygen can transfer between the atmosphere and the water. So because of the dissolved oxygen and the transfer of air, it enhances the water quality of a new water reservoir. And for example, in New South Wales in Australia, when 90% of the surface was covered by this method compared to a control group that didn't have any cover on the surface, 80% of the evaporation was reduced. And similar example, in Queensland, Australia, when 80% was covered, 73% of the evaporation would be reduced compared to the control group. And compared to other methods of dam evaporation control, such as chemical methods, which deploys a chemical film on the surface of the water, this has a great advantage of lower maintenance costs than those methods because once you deploy the waters into the water, you don't really have to maintain costs through it, because for chemical methods you have to regularly pour the chemical films into the water surface to make it effective, but in this case you just have to deploy it once and it's going to be stayed for a while and prevent the evaporation. This is a good example of it. It's 2015 in LA because there was a great drought in LA In 2015, the LA Department of Water Safety, they deployed 96 million shade bars to cover up the LA water reservoirs, and yeah, it turned out to be very effective for preventing water evaporation. So in conclusion, to remind you again, for the water crisis in our global society, so it is predicted that 10 billion, the world population is predicted to be 10 billion, and along with the increasing population, there's going to be more serious climate change, and it's going to lead to more scarcity of water, and more nations is going to face water crisis. And the agriculture sector is, saying all my time, it's very responsible for this problem because of unsustainable agricultural water management, and these three solutions, precision irrigation technique, drip irrigation, such as BRI, and drought resistance crops, and limiting water evaporation through dam evaporation control could prevent this from and lead to a more sustainable agriculture practice in terms of water management. There's still a lot of limitations such as cost and effectiveness that a lot of other countries who doesn't have much capital it's not easy to implement these problems, but I think starting to have interest and invest in this problem is going to be the first step to lead to more brighter and sustainable agricultural practices that could lead to a better society. And these are three among the UN goals. Number 6, 9, 12 that I mentioned before, it will be a goal that we should do in the future.
Now, these three goals, especially